Today we're going to talk about the probability and the multiplication rule. Let's take an example to show what's the meaning of independent events. First of all, a compound event or composite event consists of two or more simple events. So if we have two or more simple events together, this would be called a compound event. The independent events are two or more events in which the outcome of one event does not affect the outcome of the other events. As in this example, suppose a coin is tossed and the spinner shown is spun. So we have a coin with head and tail. Okay, so we have a coin tossed and we know that the faces are head and tail. Also, the spinner here has three colors or three numbers with different three colors. Suppose the coin is tossed and the spinner is spun. The sample space for this experiment is, of course, if the coin had a head, if it was tossed on the head, the spinner can have, so let us make it as a tree diagram and let's see the sample space. Either head or tail. The head can take, after that, the spinner can be spun on 1, or can be spun on 2, or can be spun on 3. Also for the tail, it can be spun for 1, 2, or 3. So the sample space will be H1, H2, H3, T1, T2, T3. And remember, in the counting principle, the number of all possible outcomes in this sample space is the number of possible outcomes in the first event, which is 2, multiplied by the number of possible outcomes in the spinner, which is 3. So 2 times 3 equals 6. As you see here, these are the sample spaces. So using the sample space, the probability of the coin landing on heads and the spinner on 2 is the probability of head and 2. So what is the probability of the head and the number 2? It's only this one. So we have only one possible outcome for this event, which is 1. And of course, the probability is 1 over the total possible outcomes, that is 6. We can find this also by multiplying the number of heads, or the probability of heads, multiplied by the probability of having a number 2 on the spinner. If you multiply 1 over 2 times 1 over 3, it will give you also 1 over 6. So this gives us the rule, which is the probability of two events which are independent. If two events A and B are independent, then probability of A and B equals probability of A multiplied by probability of B. So this is the rule for the independent events. And again, what are independent events? They are events that do not affect each other, like tossing a coin and spinning a spinner. So these are called independent events. Okay, so let's look, as we know, if that we have independent events, of course we have also dependent events. So what are dependent events? Are two or more events in which the outcome of one event affects the outcome of the other event. Like in this example, suppose we have a bag containing marbles, red marbles and blue marbles. 5 of them are red and 2 of them are blue. Suppose a marble is chosen from the bag and placed on the table. Then another marble is chosen from the bag. So when choosing the first marble, there are 7 possible outcomes. Of course, we have 7 total here. So the first one will have, what is the probability that it will be red? It will be 5 over 7. Because there are 5 red and the total is 7. So it will be 5 over 7. When you place it on the table, how many remaining now in the bag? There are only 4 red remaining, and the total will be now 6. So the remaining are, or the probability of choosing another one red is 4 over 6. So this means that the probability is 5 over 7 times 4 over 6. So let's write it here. So the probability of choosing a red one in the first time, and then another red one in the second time, this will give us 5 over 7 multiplied by 4 over 6. So if two events A and B are dependent, because one of them affects the other. Because when I take a marble and I place it on the table, okay, so now the number of marbles in the bag have been decreased by 1. And also the number of marbles, if it is red, are decreased by 1. So they are dependent. So the probability of event A and B is probability of A multiplied by probability of B, given that A has happened. Let's take this example. Determine whether the events are independent or dependent and explain your reasoning. One spinner is spun twice. If one spinner is spun twice, so the first time and the second time are not affected by each other. So of course, these are independent events because they do not affect each other. In a raffle, one ticket is drawn from the first place prize, and then another ticket is drawn for the second place prize. So of course, the first one will be taken. It will affect the number of raffles for the second one. So this means that they are affected by each other, or the second one is affected by the first one. So they are dependent events. A random number generator generates two numbers. Of course, it generates the first number and it can generate the second number and by not depending on the first one. So they are independent because they do not affect each other. The pizza that Josie and Tessa are eating has 10 slices and is half cheese, half mushroom. Tessa spins this pizza around and randomly selects a slice of mushroom pizza. If Josie spins the pizza and selects a slice after that, what is the probability that both he and Tessa select a slice of mushroom pizza? We know that they are half mushroom, half cheese, so this means, and they are total of 10 slices, so this means that the mushroom is 5 out of 10. This is for the first spin. The second spin will be 4 over 9 because they have been affected by each other, and the total will be 2 over 9.